Good morning, students. In previous class, we were discussing about the types of system, and in that we discussed mainly about the time invariant system and the time variant system. And after that, we discussed about the stable and unstable system also. Clear? So that was the type of system that we studied in the previous class. Now today, I'll just give a brief introduction about one more system in which the question was given invertible and non-invertible. Invertible and non-invertible system. Now this is again another type of system in which we should know what is an invertible system and what is a non-invertible system. Now you must be knowing about the thing कि कोई भी चीज if we are writing anything like suppose yt is equals to xt. In that case directly if we are, let us just take another example. Let us talk about a set. That is, I'm having a set of inputs xt. I'm having another set of inputs yt. Okay? Now here I'm having different inputs like a, b, c. These are my different set of inputs. Now here I'm having different sets of inputs like p outputs p, q, r, and suppose let us say s. So these are the set of outputs and these are the set of inputs. Now for individual a, I'm getting an output p. That is, if my xt is A, I am getting an output P. If my xt is B, I am getting an output Q. If my xt is C, I am getting an output S. That is, for a particular input, I am getting a particular output. So in this case, for A, I am getting output P, B, I am getting Q, C, I am getting S. That means it is 1-to-1. This is a 1-to-1 case. For a single input, I am getting a single output. There is no like clashing. So if it is a 1-to-1 system, we are saying that this one is an invertible. Okay? If it is 1-to-1, that is for a single input, I am getting a single output. In that case, it's an invertible system. Okay? Now, if we just check that if A is producing an output P and if B is also producing an output P, so ये क्या हो गया? That is 1-to-many. For many inputs, I am getting a single output. ठीक है? और ये भी हो सकता है कि C में भी मुझे output P ही मिले. So for the set of inputs, I am getting a particular output P. So this is 1-to-many input. In that case, this is a non-invertible system. This is very simple to understand that for any set of inputs, I am getting a particular output. In that case, it is a invertible system. And for the set of inputs, I am getting a common output. It is 1-to-many. It will be a non-invertible system. ठीक है? तो यहीं से आपका ये clear होता है कि 1-to-1 है तो invertible है. If it is 1-to-many, it will be a non-invertible system. ठीक है? Now let us say if y of t is xt plus 2. Y of t is xt plus 2. Now what is it? Whether it's invertible or non-invertible. Now if I give the values of xt, then the set of yt I get. If my xt, what is it? If my xt is minus 2, ठीक है? अगर ये minus 2 रहता है, yt will be 0. If my xt is 0, yt will be 2. If my xt is 2, yt will be 4. That is, for particular set of inputs, I am getting particular set of output. So what kind of system this one? What kind of system is this? कैसा system है? Is it an invertible or non-invertible system? Yes, students reply. It is an invertible system. It's very true that it's an invertible system. Now if I take the example, y of t is x square t. ठीक है? Now for set of inputs, what are the outputs that I am getting? Let us check. ठीक है? If I am writing x of t as minus 2, if I am writing x of t as minus 2, what will be my y of t? It will be plus 4. If I am writing x of t as 2, again my y of t will be plus 4, right? Minus 2 के लिए भी 4 है, and for plus 2 also it is 4. So what kind of system this one? This one is a non-invertible system. This one is a non-invertible system because for certain set of inputs I am getting a common output, so the system is a non-invertible system. Okay? So the concept of invertible and non-invertible is clear, I guess. So that is how you have to check in the question that was given to you as an assignment in assignment. तो उसको आप करोगे questions को, just solve all the questions that were given, and all the questions are easy. You can easily solve them. Try to solve it. If you are unable to solve any of the question, definitely we'll discuss it and I will tell the solutions of it. ठीक है? अगर नहीं हो पाएगा तो, but try yourself first. ठीक है? So most of the questions we have already done. Most of the type that we have already done are given in the assignment question. So here we are done with our first unit. Now let me start with the second unit. Sorry, fifth unit. I'm starting with fifth unit now. Fifth unit is a linear time invariant system. Now we already know what is a linear. Unit 5. It's a linear time invariant system. Okay? So this is the Unit 5 linear time invariant system. Now here we have to understand the two important attributes which are linear and time invariant. We already know what is a linear system and what is a time invariant system. ठीक है? हमने conditions भी check कर लिए कि when the system is a linear system and when the system is a time invariant system. Now it is combinedly taken as a system which is linear also and which is time invariant also. So we have to check with the system which is linear as well as time invariant. Now in this one, what plays an important role is our integral. Integral plays an important role, and in this one term which comes in, which always comes and that will always come in the entire, and it is a convolution integral. Now what is a convolution integral and what is it? Now if any system is given an input xt, the output will be yt. Now if we give the input del t, if I give the input del t, what would be my output? Output क्या होगा? The output is known as an impulse response. This one is known as an impulse response, and it is represented by h of t. It is represented by h of t. If the input is xt, the output will be yt. Now if I give the input del t, the output will be h of t. ठीक है? So that we have to just remember कि अगर हम input दे रहे हैं xt, तो output is yt, and if the input is del t, the output is h of t. Now we can write this h of t is transformation done on del t. Transformation done on del t. Clear? So h of t is transformation done on del t. Now we can write in terms of xt, in terms of del t also, that is integration minus infinity to infinity. Let us take another variable which is tau. This is another variable as tau, x of tau. Then this becomes t minus tau. This one is t minus tau. So here it is again t minus, this is d tau. Okay? So xt is equals to integration minus infinity to infinity x of tau del t minus tau d tau. Now here the variable is not t, variable is tau. Tau is my variable. Hence we have taken in terms of d tau. As we all know, by the property of the impulse response, कि ये अगर हम लेते हैं del t minus tau, t is a term, any constant value. T is any constant value or anything. ठीक है? So if t is any other value and tau is my variable, so if in this case, if I take the integration minus infinity to infinity, x of tau is my any input, and this is del t minus tau. In this one, in this entire term, what will be the output? That is x of tau will exist only at this value. X of tau will exist only at this value of t. Is equals to integration minus infinity to infinity x of tau then t minus tau. So that infinity x of tau then t minus tau because of the property of the del, that is the impulse function. Okay, now this one, as we have written this one, if I write, if this is the input, अगर मेरा ये input होता तो I get this one. ठीक है? Now if yt is the output, if yt is the output, I can write transformation done on del t. If yt is output, I can write transformation done on xt. ट्रांसफॉर्मेशन डन ऑन xt. ठीक है, तो ट्रांसफॉर्मेशन मेरा xt में जो भी ट्रांसफॉर्मेशन होगा दैट विल बी आउटपुट. नाउ आई कैन जस्ट रिप्लेस दिस xt बाय दिस एंटायर टर्म. दिस इज व्हाट इंटीग्रेशन माइनस इंफिनिटी टू इंफिनिटी x ऑफ टाउ del ऑफ t माइनस टाउ d tau. ठीक है, तो दैट इज व्हाट इज द ट्रांसफॉर्मेशन done on the entire xt. Now this can be further written as integration. What is actually my input? Input is this one. ठीक है, input क्या है मेरा? ये है. So we need to write it in this form. So this becomes minus infinity to infinity. This x of tau is remaining as it is, and here the transformation will done on what? It will done on del t minus tau. Now since this is del t minus tau, तो इसी पे जो आपका ट्रांसफॉर्मेशन होगा it will be done in this part only. सिर्फ इसी पार्ट में आपका ट्रांसफॉर्मेशन होगा. Clear? So this is how the transformation has been given to this one. Since this is my input, तो यहाँ पर मेरा ट्रांसफॉर्मेशन इस पार्ट में हो जाएगा. ठीक है? Now after this, if I take the another step of this, if I am taking h of t is what? It is the output when the input is, when the transformation done on del t. H of t is the transformation done on del t. Now since the system is a linear time invariant system, so h of t minus tau will be equal to what? The transformation done on del t minus tau होगा. Whatever is the transformation done on del t minus tau will be h t minus tau. So this can be replaced by h of t minus tau. Now yt can be further written as integration minus infinity to infinity x of tau. This can be written as h of t minus tau d tau. So this is my final yt, and this is how we can get the formula for the convolution integral. Yt is what? Integration minus infinity to infinity x of tau. This one is x of tau, and this is h t minus tau d tau. ठीक है? x of tau h t minus tau d tau. So that is how we can derive our equation. Now this is the impulse function. On the basis of the impulse function we have written. Now this is what is, if you write in terms of convolution integral. Suppose I have a system. This is LTI system. This one is LTI system. When I give the input del t, I get an output h of t. When I give the input del t, I get an output h of t. When I am giving an input xt, I will be getting an output y of t. I will be getting an output y of t, and this is what? This is nothing but x of t convolution h of t. X of t convolution h of t. So that is what we need to understand. अगर हम input del t देते हैं, if we are giving an input lt, we get the output as impulse response, that is h of t. Now when we are giving an input xt, any particular input xt, we get the output yt, and yt is the convolution of the input xt and the impulse response. ठीक है? It is the convolution of xt and impulse response. Xt convolution ht, and this can be written as written as x of t convolution ht is nothing but integration minus infinity to infinity x of tau, any other variable tau, h of t minus tau d tau. This is how it is defined. Now you need to remember this formula. You need to remember this formula because this is an important formula throughout the convolution, that whenever throughout the unit in fact, कि जब तक आप ये करोगे तब तक आपको ये फॉर्मूला याद रखना है, that what is my y-t, it is xt convolution ht and that is integration minus infinity to infinity x of tau h of t minus tau. ठीक है? Now we'll just go through with the properties of the convolution integral. Properties of convolution integral. Properties of convolution integral. First property is the commutative property. Commutative property states that if we are writing xt convolution ht, this is same as we write ht convolution xt. xt convolution xt मतलब कोई भी सीक्वेंस में हो सकता है. It could be either xt convolution ht और ht convolution xt. तो अगर we are taking xt convolution xt, तो ये क्या हो जाएगा आपका? ht convolution xt होगा तो this becomes h of tau and this becomes x of t minus tau. होगा ये. तो this can be taken in any of the sequence. कि किसी को आपको first लेना है, किसी को second लेना है, that is up to us. हमें जो भी है accordingly as per our convenient we can take. Either we can take xt convolution ht or else we can take ht convolution xt. That is our first property. Second property is associative. This is commutative. The second one is associative. Now associative property states that xt convolution. Now here we have two h terms, that is h1t. First let us take h1t convolution h2t. Now we have two impulse responses, h1t and h2t. So in that case, if I am having xt as my first convolution integral and this one is the second convolution integral, in this case मेरा ये जो sequence है ये भी आपका change हो सकता है. Now here I've taken, let us take two convolution integrals h1t and h2t. Now in this case I can even take xt convolution h1t first and then convolution h2t. So that is what is commutative property, which states that कि मैं कोई भी term को कभी भी ले सकती हूँ. ठीक है? xt convolution h1t convolution h2t. Here I have three convolutions, h1t convolution h2t first हो रहा है and then it is getting convoluted with xt. Now here what I am doing is I am convoluting xt convolution h1t first and then I am convoluting it with h2t. So any of the convolution can take place at any point. किसी भी sequence में आप उसको लेकर convolution perform कर सकते हो. Now the next is the distributive property. Third one is distributive property. Now distributive property is an important one in which it is saying that if xt is getting convoluted, xt is getting convoluted with two impulse responses which are the sum. ठीक है? यहाँ पर h1t plus h2t है. It is not the convolution as we did in the case of associative. Associative में हमने convolution किया था. But here in the case of distributive, this is h1t plus h2t. ठीक है? h1t plus h2t है. तो in that case, as we used to do, individually दोनों आपका convolution हो जाएगा. x of t getting convoluted with h1t plus x of t convoluted to HQT. ठीक है? So this one is distributive property. This one is distributive property. Clear? Now the last one, fourth one, which is the important one, convolution integral operation. Convolution integral operation, as we already know, y of t is what? Y of t is x of t convolution h of t. This can even be written as h of t convolution x of t. I can write it in this way also because it is x of t convolution h of t. As we have already taken, we can even write it in this form. तो ये क्या हो जाएगा? This will be minus integration to integration h of tau. This becomes h of tau x of t minus tau d tau. ठीक है? तो convolution integral operation according to the commutative property. Commutative property can be written in this form also. ठीक है? So these are the properties of the convolution integral which we should know for solving the questions. Are these properties clear to everyone? Anyone having any doubt in the properties? Yes? It's clear, right? Clear everyone? So now we'll solve the questions based on this. I'm rubbing it out. Now write down the questions based on this. This is the convolution integral. Now this is an important question. Let us just do it because the question is very important. ठीक है? First question, write down. Now the same thing happens in the case of discrete time also. Discrete time में भी हम same ही आपका रहता है. Everything, all the properties will be बिल्कुल same as according to the discrete time. ठीक है? जैसे आपका continuous time का we have discussed, will be having the same thing in case of discrete time also. ठीक है? Now let us start with the first question. ठीक है? If the input xt is given by ut, if the input xt is given by ut and h of t, the impulse response, is given by e to the power minus at into ut for a greater than 0, for the values of a greater than 0. Now we have to compute, we have to obtain the output y for this xt and for this h of t. Clear? For this xt and for this h of t, that is xt and the impulse response h of t of a continuous time LTI system. This is a continuous time LTI system and we are talking about the continuous time LTI system always. Either it will be a discrete time LTI system or it will be a continuous time LTI system. That will always be there because the unit itself is a LTI system. Okay? So that we don't have to forget anyway, it will always be a continuous time LTI system. Clear? So this one is xt given as ut and h of t, the impulse response is given as e to the power minus at into ut for a greater than 0. This one is an important part. Now we know that this is what xt convolution ht. ठीक है? xt convolution ht. Now this can be written as integration minus infinity to infinity. This is x of tau h of t minus tau d tau. ठीक है? So x of tau is what? If I take xt as ut, x of tau will be what? U of tau. It will be u of tau, right? Because I am changing the variable, it is changed and that becomes u of tau. ठीक है? So my x of tau here is u of tau and this one h of t minus tau. H of t minus tau. Here this is h of t. Actually the variable here is ht, but here the variable is tau. So just don't get confused with that. Here the variable is t and here the variable is t minus tau, that is the variable is tau, and from which by which factor we are just shifting? By the small t factor. So how can we write h of t minus tau now? h of t minus tau कैसे लिखेंगे? First, let us write h of tau. ठीक है? h of tau will be e to the power minus a tau. होगा h of tau will be e to the power minus a tau. And if I write h of minus tau will be what? क्या हो जाएगा ये? What is going to be h of minus tau? Here this will be shifted. ठीक है? e to the power minus a minus tau. होगा कि नहीं? Just tell me, students, reply fast. What is it? होगा कि नहीं? Is this part clear? We are just going one by one so that this becomes clear to you. ठीक है? Here it is, I have taken h of tau. h of tau can be written as e to the power minus a tau. Now this one is h of minus tau because we want h of t minus tau. So this is h of minus tau will be e to the power minus a minus tau. Now what is going to be h of t minus tau? Now wherever I am having minus tau, it becomes t minus tau. This becomes e to the power minus a t minus tau. होगा ये? This is going to be this one, right? T minus tau क्या हो जाएगा? This one minus a t minus tau. ठीक है? Now this can be further written as we have taken this one, तो इसको हम directly अब formula में apply कर सकते हैं. Phi of t is integration minus infinity to infinity u of tau. What is my x of tau? It is u of tau, and h of t minus tau is e to the power minus a t minus tau d tau. ठीक है? So this is going to be the integration part. Now in this one we know we have a term u of t also. इसमें u of t भी है, तो यहाँ पर हमारा I just forgot this one u of t. h of t में u of t भी है. So this will be u of tau, and here it is u of minus tau. ये भी हो जाएगा. ठीक है? t minus tau हो जाएगा. Correct. We'll be having u of t minus tau d tau. ठीक है? We will having u of t minus tau d tau. ये होगा कि नहीं? Because we are having u of t as well in ht. So this will also be there. Now we just have to focus on this and this because this will decide our range. ये हमारा range decide करेगा. u of tau कहाँ से कहाँ तक exist करेगा? In which range u of tau will exist? Yes? In which range u of tau will exist? Reply fast, students. We don't have much time. We have to complete most of the syllabus now. Second unit हमें पूरा complete करना है before city. U of tau will exist in which range? जैसे ut exist करता है for positive values of t, so it will be existing in 0 to infinity. T से नहीं, 0 to infinity. Correctly. So this will exist for 0 to t. So if we plot u of tau, it will be this one. ठीक है? तो ये आपका 0 से पूरा positive value of t तक exist करेगा. This is nothing but if I take u of tau. ठीक है? Now if I have to plot u of t minus tau, u of t minus tau मतलब this is itself is a minus tau. Minus tau मतलब it is in negative direction. ठीक है? Now here the value of t matters. Value of t matters whether t is a positive value or t is a negative value. ठीक है? Now let us take if t is somewhere here for plotting u of t minus tau, for plotting u of t minus tau. Now since my variable is tau, my variable is tau here. So if I have to plot then this one, if I have to plot just u of minus tau, तो u of minus tau तो मेरे यहाँ से start होगा. Clear? u of minus tau if I have to plot. Just listen very much carefully, student. If I have to just plot u of minus tau, so minus tau will just start from 0 and it will go in the negative tau side, right? It will go in the negative tau side. But here t is also here. Now if t is a positive value. If it is greater than 0, then in that case it will start from here and it will go in this direction. Is this plot clear? U of t minus tau. Is this plot clear, students? ये clear है कि नहीं, जल्दी से बताओ. Is this plot clear or not? Everyone reply fast. U of t minus tau, if I just don't take this one, अगर मैं सिर्फ minus tau लेती हूँ, it will start from 0 and it will go in the negative tau direction. But since here I am having t, which is t minus tau, so it will start from here if t is a positive value and it will go in this direction. And in इसी में ही, if this is a tau and if t is any negative value, if t is any negative value, it could be either a positive value or it could be either a negative value. Then in that case, it will start from here and it will go in the negative tau direction. ठीक है? तो दोनों अलग-अलग होगा. In both the cases, the plot will be different. This is for positive value of t and this is for negative value of t. मतलब अगर t is a negative value and this one is the plot if t is a positive value. तो दोनों को हमें consider करना है. ठीक है? Now let us take this one. Coming back to this one. So what is common as we have to multiply this one and this one? What is common if I take t greater than 0? What is common if I take t greater than 0? What will be my range? Yes, what will be my range if this and this gets multiplied? 0 to t, correct. If t greater than 0 है, तो आपका 0 से t ही आपका common रहेगा. And the rest of the cases, because this part will be 0 since this is 0 and this part is also 0 because ये आपका 0 है. ये आपका 1 है, but here it is 0, so it will be just 0 to t. For t less than 0, we won't be having any common area. Multiply हो रहा है, तो it will be 0 itself. ठीक है? So this will have to consider for t greater than 0. For t greater than 0, yt is integration. The limits will change from 0 to t. The limit will change from 0 to t, and this will be e to the power minus a t minus tau t tau. अब सिर्फ इसी को हम लोग को इंटीग्रेट करना है. ठीक है? We just have to integrate this part. Now we can even take out this e to the power minus at as common, and this becomes e to the power a tau. So if I integrate it, what is it? This becomes by t. This will be taken out this term because this is just a term. This t is just a term. So this will be taken out e to the power minus at, and inside the integration 0 to t, this will be e to the power a tau d tau. ठीक है? And later it is e to the power minus at, and this will be e to the power a tau by a with 0 to t as the limit. ठीक है? If you integrate it, this becomes e to the power a tau by a with 0 to t as the limit. तो ये क्या हो जाएगा? y of t is what? कितना आएगा? जल्दी से बताओ इसका आंसर. e to the power minus at is already here, and inside it will be e to the power at minus e to the power 0 by a. ठीक है? तो this becomes 1. e to the power 0 is 1, and here it is. If this gets multiplied, e to the power minus at plus e to the power 18, ये आपका 0 हो जाएगा. ठीक है? e to the power minus 80 into e to the power 80 minus this is 1, so e to the power minus 80 by a, and this becomes minus 80 plus 80 is e to the power 0. This is 1 minus e to the power minus 80 by a. Now this is the answer. ठीक है? ये आपका आंसर आएगा finally by t. Is this part clear, students? किसी को कोई डाउट है तो पूछ लो अभी, ये पार्ट क्लियर है कि नहीं, बिकॉज दिस इज वेन इंपॉर्टेंट पार्ट, ये आपका एक एक चीज क्लियर होना बहुत जरूरी है। 1/a 1 माइनस e टू द पावर माइनस 80 इज द आंसर। ये क्लियर है कि नहीं? टेल मी फास्ट, जल्दी से बताओ क्लियर है कि नहीं। एवरीवन रिप्लाई फटाफट। इज दिस पार्ट क्लियर? I'm not getting any reply. Yes. One more reply. Now next one. Next, let us take another question. It is just the matter of the limits. आपको सिर्फ limits पे ही focus करना है. If you are very much clear with the limits, you will definitely get the answer. ठीक है, बहुत easily you will be able to solve the question. If you are clear with the concept of limits, how to apply the limits and how to get the answer of it. ठीक है, और उसका कैसे range आपका change होता है by changing the equation. Let us take xt. Second question, xt as e to the power 80 u of minus t. ठीक है, e to the power 80 u of minus t for a greater than 0. ठीक है, e to the power 80 u of minus t, remember, and h of t is e to the power minus 80 u of t. ठीक है, e to the power minus 80 u of t. So here in both the cases we have taken ut ut. xt में भी ut है और ht में भी u of t है. So in both the cases we can solve, either we can solve it by xt convolution ht, or we can solve by ht convolution xt. So let us solve y of t as xt convolution ht, and this is minus integration to integration. क्या हो जाएगा मेरा xt, मतलब this becomes x of tau h of t minus tau d tau. This is the formula. Let us first write the formula. ठीक है, now what is my x of tau? x of tau क्या हो जाएगा? e to the power a tau u of minus tau. ठीक है, this will be x of tau e to the power a tau u of minus tau. Now what is going to be my h of t minus tau? ठीक है, t के जगह पे t minus tau आ जाएगा, तो this becomes e to the power minus a t minus tau u of t minus tau. ठीक है, so this will be the term x of tau and h of t minus tau. Now when applying the formula, this will be minus infinity to infinity. This is my x of tau e to the power a tau u of minus tau. Then this is h of t minus tau e to the power minus a t minus tau u of t minus tau d tau. ठीक है, now what is the range by taking this one and this one in consideration? अब मुझे आप range बताओगे. How my u of minus tau will be plotted? U of minus tau will be plotted in this way. ठीक है, this will be u of minus tau. ये होगा u of minus tau. Everyone, is this thing clear? u of minus tau, it will be plotted in this way. ये ऐसे plot होगा. ठीक है, now if I have to take u of t minus tau, u of t minus tau as we have already plotted, it will depend on the value of t. तो पहले भी हम plot कर चुके हैं. For t greater than 0, it will be plot in this way. That is u of t minus tau, and for t less than 0, it will be plot, if this is t and this is t, this will be plot in this way. Is this plot, are these plots clear everyone? ये plots clear है? U of minus tau will be this one. ठीक है? This is U of minus tau. हमने लिखा T to minus infinity. ठीक है? Let's see. तो यहाँ पर if we are taking these two in common, if I am taking these two in common, we'll have different cases. Amit, here we'll have to take these two cases, that is u of minus tau and u of t minus tau for t greater than 0. अगर t greater than 0 है, it will be different. t greater than 0 है तो क्या हो जाएगा? What is common for t greater than 0? What is common? Tell me fast. For t greater than 0, what is common? It is minus infinity to 0. Correct. It's from minus infinity to 0. It will be minus infinity to 0. But if t is less than 0, if t is less than 0, what is the case? क्या हो जाएगा? T is less than 0. It will be minus infinity to t. We have to take minus infinity to t. So for both, मतलब दोनों के लिए अलग-अलग cases में हमें solve करना पड़ेगा. That is, yt will be first case for t greater than 0. This is my first case for t greater than 0. This becomes for t greater than 0, it will be minus infinity to 0 for t greater than 0. Here we will write for t greater than 0. ये important है, for t greater than 0 लिखना important है, ठीक है? Because we have to take two cases. For t greater than 0, it will be minus infinity to 0, minus infinity to 0, and this will be e to the power a tau, this one, and then we have this e to the power minus a t minus tau d tau. This is for t greater than 0. हमारा t जब greater than 0 है तो now let us solve for this first. ठीक है? If yt is this one, that is for t greater than 0. ठीक है? Limit is minus infinity to 0 e to the power a tau, and this becomes e to the power minus at, and then e to the power a tau again, and then d tau. ठीक है? So here we have e to the power a tau, e to the power minus at, e to the power minus minus gets plus, e to the power a tau again, and this is d tau. And what is it? इसका आंसर क्या आएगा? जल्दी से बताओ. This will be, this is our variable, and this is a constant tau, because tau is a variable. Don't get confused. It will be, tau will be a variable. What is the question, Shruti? Minus infinity to plus t क्यों नहीं लिए for t greater than 0? For t greater than 0, this is the case, right? तो हमने minus infinity to 0 इसलिए लिया है श्रुति, because this part is 0. यहाँ पर ये है, but here it will be 0. यहाँ पर 0 है. So what is common in these two? That we'll have to take. Clear? So which is common? Yes, correct. In these two parts, 0 minus infinity to 0 is common. Minus infinity to 0 is common. And if you are multiplying this part, that is ये t तक का part को multiply करेंगे, तो ये 0 ही आएगा, because here it is 0, here we are having value. But since this is the common area where both are there, ठीक है? तो common लेना है. Here हमेशा हमें common area लेना है where we have both the plots, जहाँ पर दोनों plots exist करते हैं. Because it is ut, तो यहाँ पर एक में अगर नहीं होगा तो ये दोनों multiply होकर 0 ही हो जाएगा. Clear? That will be 0 only. तो you'll have to be very clear, very much clear कि जो common area है दोनों में वही part को लेना जहाँ पर दोनों plot हो रहा है. Clear ना? अभी तो doubt नहीं है? Okay, right? ठीक है. So here we have taken common in both the cases. Now we have to remember that this one is our variable. ये हमारा variable है. ये हमारा constant है. This will be taken out. E to the power minus 80 will be taken out, and this one becomes e to the power 2a tau. So e to the power 2a tau by 2a, and the limit will be what? Minus infinity to 0. कितना आ रहा है इसका आंसर? जल्दी से बताओ. इसका आंसर क्या है? When we apply the limit, if we apply the limit, this becomes yt is equals to e to the power minus at is taken out, e to the power 2a0, 2a is taken out, minus e to the power 2a minus infinity. Minus infinity is 1 by infinity. Either we can take it as 1 by infinity, and this value is what? It is 0. And 2a0 is what? E to the power 0. This value will be 0 and this value will be 1. So the answer is e to the power minus 2a t by 2a. ये आंसर आएगा. Is this thing clear everyone? ये इंटीग्रेशन क्लियर है कि नहीं? Just tell me fast if this one is clear or not. Anyone who is still not clear? This is just an integration. Applying the limit, will be getting this as an answer. ठीक है? तो integration part should be very much clear to you. This is how we have to solve. Now the another part is also there, that for t less than 0. For t less than 0, the limit was for t less than 0 it will be minus infinity to t. Minus infinity to t हो जाएगा. And what is it inside? E to the power a tau, and this one e to the power minus at and e to the power a tau b tau again. ठीक है, ये सेम चीज था. इसमें फिर से हम लोग लिमिट अप्लाई करेंगे. विल अप्लाई द लिमिट अगेन इन द सेम इंटीग्रेशन एंड देन फाइनली विल गेट द आंसर. ठीक है, यहाँ पर तो e टू द पावर माइनस 2a, सॉरी 1 by 2a by टू द पावर माइनस 2a आया था, माइनस 80 आया था. बट फॉर t less than 0, that is for another value of t which is less than 0, we'll get the another answer. Now what is the another answer? Just integrate and give me the answer. जल्दी से बताओ मुझे.